Okay, let's take a look at some of the problem-solving strategies that I used in solving problem number 1. So the first one I want to look at is what I call jumping around reading. Typically when you are reading a math problem or some type of math text, you don't start at the top left corner and read straight through until you get down to the bottom, and then you say, oh, I'm done, now I understand this problem. Typically, you'll start reading and then you'll stop and you'll kind of jump to another part of the problem. Like you saw me start up with reading the text and then maybe jump down and look at the answer choices, get a little information from there. Then maybe go back to the text, then maybe go back to something that you're writing down, taking notes on, or writing down some symbols or something. That jumping around style of reading is very common in reading mathematics texts and mathematics problems. So that was a strategy that I used. Another strategy that I used, translating words into symbols. And you saw me doing this in a few different ways. One way is we talked about something called math words. And in particular for this problem, the words is, which we noted in math problems very often means equals. And we also looked at the word of. That's another math word that frequently when you see it in a math problem or some type of math text, typically that will mean multiply. And so we saw both of those words, we saw me using both of those math words and translating those into mathematics symbols. Also related to translating words into symbols, I used a strategy that I call chunking. And you saw me do this when I, for example, drew boxes around different parts of the sentence that we were translating into mathematical symbols. We were translating it into a linear equation. And that's just a way of kind of saying, I'm going to look at this group of words as a single unit. And if you chunk up your sentence in that way, and the way I chunked it up, I chunked it into maybe 4 or 5 different chunks, then it's a way of making it easier for you to see, oh, this group of words kind of goes together, and I can substitute a single mathematical symbol for this group of words. So that's called chunking. Also related to translating words into symbols, I used a strategy that I call solve a simpler problem. And you may remember when I first started to translate the sentence into the algebraic notation, I first started out by saying, well, I said Jesse's bus ride equals Robert's bus ride. And that was kind of like the beginning of my equation. And I noted that I knew that that equation wasn't correct, but that was kind of a simpler version of the more complicated mathematical equation that I was trying to write. And so I started out with that, and then I kind of, in pieces, added on, a little bit, here's some more complicated language, here's another chunk that I'm going to add to it. But if you start out by solving a simpler problem, then often that will be a first step towards solving the more complicated problem that you're actually trying to solve. And then finally, strategy number 3 is something that you often hear teachers refer to as activating prior knowledge. When I first looked at this problem and I looked at the answer choices and I noticed, oh, all my answer choices are graphs of linear functions. Well, that gave me an opportunity to start to think about what are all the different things that I know about linear functions. Like, for example, well, y equals mx plus b is a very useful form, a very useful algebraic form of a linear function. And then I kind of went on from there. Well, for y equals mx plus b, I know m stands for slope and b stands for y-intercept, etc. So activating prior knowledge just means bringing to bear all of the things that you already know about, for example, linear functions, so that you can use that prior knowledge, these things that you already know, to help you to make sense of and therefore solve this particular problem. Now, these are not the only possible strategies that you could have used in solving this problem, and in fact you may have used different ones as you solved the problem yourself. And if so, then I encourage you to compare the strategies you used to the ones that I used, and maybe also compare them to the strategies that a classmate used, and talk about what you think are the different advantages or maybe disadvantages of the different strategies that I used and the different strategies that you used.